All right then. Hello everyone. So I'm going to be talking to you about building .NET Core apps on AWS using the serverless framework, and I'm going to speak about some of the lessons that we learned along the way. So our team's actually been building serverless applications and architectures for about 18 months now. It was driven by necessity to start with, so we've learned some pretty hard lessons. But before we get started, I'll introduce myself a little bit more. So my name's Jon Vines. I'm a software engineer and team lead. I work for AO.com. We're based in Bolton, but I actually work in the city centre of Manchester, so I've come over from Manchester today. I'm also a co-organiser of DevOps Manchester and the serverless user group in Manchester as well. And I also love reading. I love DevOps, so I like to recommend a few DevOps books, which I think should be required reading for a lot of people. So firstly, a couple of book recommendations for yourselves tonight is Accelerate by Dr. Nicole Forsgren, Jez Humble and Gene Kim. So this talks about DevOps principles and practices and why they're really good at creating high-performing teams, and also project to product, where we're talking about how the fact that we're in the age of software, and if we continue to deliver projects in the project mindset, then we're going to find ourselves behind the curve. So we should really switch to that kind of product development and product ownership lifecycle. So what we're going to be talking about tonight, so I'm going to introduce serverless, introduce a few of the concepts behind it and what I think it means. There's a lot of fad words around that. I'm also going to talk about serverless and .NET and how the numbers kind of stack up and kind of how we're left a little bit behind when it comes to developing serverless applications with .NET. We're then going to do a little bit of a demo, deploying a .NET Lambda to AWS, just looking at how the serverless framework puts things together. And then we're going to talk through a few of the lessons that we've learned along the way. So let's get started. So let's talk about the elephant in the room first. So serverless doesn't mean that servers don't exist. Of course, servers are always there. But basically, all it means is that as a developer, we don't really care about the servers. The level of abstraction we're working at means that we're working at kind of compute level. So I'm not here to suggest that servers don't exist and servers are bad. They're there, they're needed, but we're just not looking after them anymore. And a good way to sum this up is this quote from Gojko Adic, which is, serverless is the same way Wi-Fi is to wireless. So if you send a text on your phone, at some point it's going to go over a wire somewhere. So that's kind of a good way to think about it. So what is serverless? So bad name apart, what exactly is it? What are we talking about here? So the common viewpoint is that serverless is functions as a service. A lot of people think about AWS Lambda. Lambda's been around since 2014 now, so it's already coming up to 5 years. And essentially, this is a way of running back-end code without managing your own servers or your own long-lived server applications. I'm talking things like containers and stuff like that. There's a few examples of functions as a service. So I've already spoke about Lambda, but some of the other common ones are Google Cloud Functions, Azure Functions, IBM Cloud Functions. We've got open source options with OpenWhisk that you can deploy on top of Kubernetes, but then you'd have to run a Kubernetes cluster, or someone in your organization would. But for the rest of this talk, I'm going to be talking about Lambda in particular. I'm going to be talking about AWS and some of the services that we've got available to us there. But really, serverless is a spectrum, really. So functions as a service is just one piece of the puzzle when it comes to serverless. And the functions as a service can really be thought of as the glue that binds together all the pieces of that serverless spectrum where we actually run that code. Another big part of serverless is actually using managed services. And when I talk about managed services, what I mean is things like storage or messaging or API proxy. So if we think about storage, we're talking about S3 and DynamoDB. Messaging can be SNS and SQS. We've got API proxies such as API Gateway as well. But we can also start to think about some other platforms as a service. So for example, Confluent Cloud, who give a managed Kafka service, Mongo, DB Atlas as well, where basically they're taking that concern of managing servers away from you. And they're just giving you like a compute platform to build on top of. So now that we understand a little bit more about what serverless is, let's ask the question, why serverless? So why would you pick serverless? Well, First of all, it's scalable by default, so we don't have to worry about setting up things like auto-scaling groups or managing load balancers or the life cycle where that compute's being run. All that's normally built into the offering if we're talking about functions, so it's all just there for us. Serverless architectures have built-in high availability just out of the box, so they've got built-in high availability and fault tolerance, so we don't need to build these in, they kind of come as part of the package with that. They're more secure, and the reason I say that is because we're not worrying about the burden of maintaining security on our servers, so we don't have to think about the data center or the network or the servers or the operating system. We're not having to worry about patching cycles and all that kind of stuff. That's kind of managed for us by the cloud providers. But that's not to say attack vectors don't exist. So things like injection into your functions to kind of get things out of there is still a concern and still things you need to think about. But the attack vector changes, and we care about the code that we're writing rather than the underlying infrastructure, which is now the provider's concern. And they're cheaper, and this is because we only pay for the compute that we need, and when a function isn't running, we're not paying for anything. So I've included a small asterisk because we still pay for data storage. We're always going to have to pay for data storage. It's not all roses with serverless. It's not a silver bullet for building applications really quick. Towards the back end of last year, this article appeared on the Register, which says serverless is awesome if you overlook inflated costs, like distributed computing, and love vendor lock-in. But if we actually look into what they're talking about, the specific examples are not really what you'd consider for kind of serverless architectures, those event-driven types of architectures. So they were describing model training, so training machine learning models, and low latency prediction serving. Now, if any of you are like me, I tend to build applications that are either CRUD for a website or some event-driven back-end processing. So these kind of use cases I'd suggest aren't the ones that we'd want to build in our serverless application architectures. And I'll finish with a small analogy. So does anybody here go to the gym? This is a good way to think about it. So if you think of yourself as the function and you want to go running, then the cost of that run is the time you've spent and the energy that you've exerted to do the run. If you have a gym membership and you actually pay for the gym, then the gym is the server in this case. So you can go and run at the gym and you're still spending the same amount, but when you leave the gym is still there and you're still paying per month. So if you go or not, you're still paying for that gym to be there. So that's a nice way to think about it, really. I prefer to run on the street. Perhaps the biggest benefit of adopting serverless is actually reducing undifferentiated heavy lifting, so we're not having to worry about building all of that infrastructure up to get something up and running quite quickly. And this is a quote from Jeremy Daly from a really good post, actually. It's quite a long post, basically saying stop calling everything serverless, but I like how he frames that serverless is actually a methodology for planning, building and deploying software in a way that maximizes value by minimizing undifferentiated heavy lifting. So what that means is that we're building business logic and actual code for solving the needs of our business rather than building frameworks and tools that isn't actually adding that much value. And another good take on it is this quote by Paul Johnston, which states that a serverless application, a serverless architecture, is one that costs you nothing to run if nobody's using it. And I've already mentioned excluding data costs. So what does that mean for us as .NET developers? So I've pulled out some numbers from a number of studies that are around. Firstly, the Stack Overflow Developer Survey. This shows that approximately 30% of the 90,000 respondents code in C#. It also shows that we're developing for Windows and Linux predominantly, with 26% on AWS. So we can see that there's a good number of developers out there who are using C#. There's a good number who are still deploying quite traditionally, really with Linux and Windows in the background, and a small number for AWS. But when we start to look at what that looks like in the serverless space, the numbers look really different. So this is taken from Serverless by the Numbers. It was a usage report on the serverless framework. And we can see that .NET Core usage is spread over .NET Core 1 and 2. This is from 2018, so it's a little out of date, I guess. It may have gone up another % or two, but I guess it's still pretty small. But that's less than 2%. So we've got a massive difference between the number of people who are actually coding in .NET and the number of people who are coding .NET in AWS. So that would suggest that things aren't looking great for us. And to be honest, historically they've not. There's been a lot of okay. So .NET. If you're developing .NET and you want to use serverless, you've got really two major options other than the OpenWhisk open source libraries. You've got Azure. obviously they're Microsoft. They build C# and .NET, so they're obviously going to offer functions in .NET, and AWS have got a increasingly more mature offering for .NET as well. Yeah, the graph's not great, but basically what we're showing here is just the kind of response time, the duration of the Lambda function, and how it compares to some of the other languages. So we can see that the average duration for a .NET Lambda function running is 0.37 milliseconds. This is just like in and out. There's not much business logic or anything going on in these. But we can see that it actually compares pretty favorably along with a number of other languages. So basically, I just want to show how quickly we can get something up and running in Lambda and show you what some of the lessons we've learned along the way look like. So we're going to be using the serverless framework. This is where we're going to define the stack and the resources that we want to build. So let's go ahead and write our first function. Okay. Just bear with me a second. I'm going to have to drag some windows around. Okay, so the first thing I'm going to do is just show how the serverless framework creates and bootstraps a new project for us. Can everyone read that? Make it a bit bigger. So I'm just going to create a new template based on C#, and give it a path of dotnetsheff. And this will just create a new serverless framework project for us. So once that's done, has that done it? So this gives us a really simple kind of C# project to start with. I'm just going to restore this. Essentially what we've got is a handler here. This expects a request and it'll give a response. We also get a build script here, which basically allows us to package that Lambda, create the zip file for us, and then we also get a serverless.yaml file with a few basic defaults in there, but also some hints as to the other stuff that we want to include as well. I'll close this down. I'm going to start with something that I wrote earlier, just to deploy that. So within here, if I do serverless deploy, that. Again. So whilst that's going off running, what this is actually doing is creating an S3 bucket. It's going to upload a CloudFormation file taken from the serverless YAML to define the stack that we're building. It's also going to upload the artifact for us. It's then going to create the Lambda function actually pointing to that artifact as well. So what this is doing is creating the stack. If we look in AWS in the management console, we can see what it's actually created. So within S3, we can see dotnetsheff demo just here, and we can see within this folder we've got the JSON, the CloudFormation template, and we've also got the package zip. If we go into Lambda, we can see what it's that it's created the function for us. It's still doing it at the moment. There you go. So if we refresh now, so we can see that this has created the function. So we've got something up and running pretty quick. But at the moment, that function is pretty useless, to be honest. So I'm going to give it a little bit more. So what I'm going to do here is just give it an API endpoint so we can actually invoke this via the API. So this should allow us to then invoke an API endpoint, and we can very quickly see that we've got some function being invoked via an API up relatively pretty quickly. If we go back to the interface, we should see this API pop up in the API gateway. So we can see that there now. So that's coming in. We're just waiting for that to complete. And then we should be able to invoke this. And this will give us, it's basically just a hello world function this, so this is going to give us an API gateway response back. We've got hello.NET So let's take it a little bit further than that. Let's actually write some data in. We'll store it on a database in DynamoDB. And I'll take you through what is actually in this serverless file as well. So we've got a few different things in here now. We're actually defining a few resources. So we've got DynamoDB table here with some very basic default settings in there, but what that'll actually do is go off and create that DynamoDB table for us. Along with that, we've got this new IAM role statements. So this means that any function that we define within the serverless stack actually gets the IAM permissions to go and invoke that function and use the resources that we're defining in AWS. And we've also got this new handler in here now for giving feedback. So let's get this deployed, and then we can see what that looks like. So whilst that's deploying, we've already spoke that functions need to be triggered. So what we've done so far is just define an API gateway, and that's a very simple use case. We've all written APIs, but with AWS, there's actually up to 47 different types of triggers that we can use. So this is from a lot of the other services that we've got there. So things like Kinesis, SNS, SQS, CloudWatch itself, DynamoDB updates, deletes in DynamoDB, S3 as well. So there are loads of different triggers we can use. And when I spoke earlier about Lambda being the glue that ties these together, so based on something happening within any of these services, we can write some custom function to do something based off that event as well. Okay. So that's now deployed. So before I do that, I'm just going to show you in here, DynamoDB, that we have a new table. So we've got this table. There's no items in there at the moment. I can invoke this. Didn't work. There we go. I'm obviously going to rate myself pretty good, 10 out of 10. I'm not sure if it'll be 10 from the rest of you. But if we go back here, we can see now that we've got data in DynamoDB. So very quickly, we've got something up and running. The code for that is pretty straightforward as well. If we have a look in here, so we've just got save feedback, and there's basic DynamoDB invocations into there. We can also create triggers off that DynamoDB insert now, so we could do something off the back of that, maybe send emails or whatever it is we want to do as well. Okay. So what has that looked like for us? So like I say, we've been building serverless applications for about 18 months now, and they've got increasingly complex over that time. It started very simply with API gateway, create request, and into a database. But what we've got here is basically the ability for people to upload files into S3. And this is to fulfill things like GDPR. So we capture like subject access requests, and we expect people to upload documents that we can then send back to the customer. So people within the business upload via a website into S3. We create a signed URL into S3. Once that file hits the bucket, we create a trigger into Lambda, which then zips up all of the files related to that request, creates a zip file, then fires into an SNS topic, which then updates the request to say this is the zip file you need to use if we're going to send this data back to the customer, and updates that in the database. So we've got a quite nice event-driven architecture. There's very low code in there, and we've just focused on writing the code that we needed. We've also got this streaming data ingestion. So we capture a lot of data via CDC from SQL Server, and we use Kafka to get this data into. So this the data into Kafka. So this was to basically allow us to capture data within the enterprise without expecting those legacy teams to write custom code to fire events into Kafka. We've then got a number of connectors which push that data into S3 buckets. And again, we're following the same thing. Once that data hits S3, we're triggering SNS, SQS, and a number of business logic rules to create new views on that data to solve different business needs. That then gets stored into a MongoDB where we've got a view of that data and what it looks like. And then we've got a number of applications based off the back of that to give insights and new applications for our customers. So what are some of the things that we learned along the way? So chaos engineering was a big thing for us. We found that it was a lot harder to test these applications just by their very nature. So chaos engineering is all about essentially finding your failure modes in your application. And Gremlin define it as injecting something harmful to build an immunity. That's the kind of general definition of what chaos engineering goes about. We're purposefully trying to find those failure modes. And I think the most widely known example of chaos engineering is Netflix's Chaos Monkey. I'm sure pretty much everyone here has heard of that. But the Chaos Monkey was built for destroying EC2 instances, either shutting them down or injecting CPU spikes and that kind of thing. Obviously, in a serverless world, Chaos Monkey doesn't apply. But there's another increasingly popular method of chaos engineering known as failure injection testing. So this is purposefully injecting exceptions or latency into your functions. The way we did this was to randomly inject headers onto the requests as they're coming in. So we had a little sidecar function essentially that just randomly added things in. So we could inject latency. So X latency injection, we want 10 seconds there. And we can also inject exceptions. So this one is just saying just a generic exception fires something off, but we can target specific exceptions as well. And what this looks like is basically within the code, we just have this little class here which says, if I see this exception, then we're going to throw a new exception. If we see latency, then I'm just going to wait for that period of time and see what happens. So if we ran this, we could see with the latency injection, we've set it to 10 seconds. The amount of time we've given our Lambda function to run is 6 seconds, so we can see the kind of exceptions that we'd get in that scenario. And basically what that allows us to do is use something like Poly to create policies for for those scenarios so that we can handle them a little bit more gracefully. We can give a better experience to things like the UI as well. Debugging and observability, this becomes super hard with Lambda functions just because of the very nature. Specifically with .NET, there's not a huge amount to run that locally. You can question whether you'd actually want to run it locally because you'd have to mock all of the different AWS services, which seems a little bit pointless. One of the better ways is to use CloudWatch. Obviously, you can console log out to CloudWatch, you get all your logs there, but that gets really painful very quickly, especially if you're running at quite high throughput. You'll have multiple Lambda instances up and running, your logs get dispersed across and they become quite hard to actually see what's going on. So what options are there with .NET? A year ago, I would have said very few. You could build your own, you could create pipelines to end up in Elastic and build your observability, but we've already spoke that choosing serverless is to remove as much undifferentiated heavy lifting as possible. So there are a few options out there now. Tundra, Dashboard and Epsagon. Of the three, Tundra's probably the most mature. Epsagon's offerings within a month, so things are still quite lagging behind here. And they probably are in general for serverless applications as well, to be honest. But this is a space where tools are growing quite fast. It'd be remiss not to talk about serverless and .NET and not talk about cold starts. So a cold start is essentially the amount of time it takes to invoke the first request. So when it's spinning up the container in the background, .NET traditionally performs really poorly here. So we can see against Java, Python, and Node that the latency to that first request is between 3 and 6 seconds, which is quite a long time to wait for a response back if we're on a website for our users and stuff like that. So what options are there? Cold start solutions. I don't think there's really a solution at the moment. I think there's a number of hacks that you can put in place to try and manage this. So firstly, you can do nothing and just accept that that happens and just try and manage that on the front end. That's not great in a lot of circumstances. Increasing the memory allocation of the function can reduce that cold start time. It doesn't get it perfect, and you're paying for kind of over-provisioning your function, which isn't a great place to be either. You can periodically warm functions, so this is known as the CloudWatch hack. You basically have another Lambda function that gets invoked every 5 to 30 minutes, that then periodically invokes the rest of your functions, and you have an escape route out of those functions, so you're not actually executing the code, but it keeps that Lambda warm. And this is the final option, which is wait for AWS to fix it. That usually comes along with the trademark 2019 or 2020, so you could be waiting for a while. And finally, cold starts are worse when you attach it to a VPC. So a VPC is your virtual private cloud. If you're accessing things like databases where you don't have that connectivity out to the whole of the internet, you're going to need to attach your function to a VPC. And that means that your cold starts are going to be exponentially worse. We've seen in some cases this take more than 20 to 30 seconds, which is pretty horrendous. Finally, just to touch on deployments. So before serverless, our route to production kind of looked like this. We chose the language and framework. We had to master that language and framework. We had to ask ourselves, are we doing microservices? Figure out what that deployment looked like. Configure CI/CD, configure the AMI or the container that we're building. Configure elastic load balancers, think about capacity planning, configure auto scaling. Usually over provision for launch because we don't know what production actually looks like. And then finally we're in production for our new service. With serverless it becomes a lot simpler. We choose a language, you master that language, and then you configure CI/CD with the commands we were using earlier, and that just creates a much simpler, streamlined deployment pipeline. We've seen in some of our applications being able to get from code commit into production in less than 10 minutes, and that's with automated tests involved as well. So it does make a big difference to that deployment pipeline. So what have we talked about today? So I've introduced serverless and what the ecosystem looks like with .NET. We've deployed on Lambda to AWS and shown what a very simple serverless architecture looks like. And then we've spoke through some of the lessons that we've learned using AWS as well. And with that, I'm done. I'm available for questions now. I'll be around for the break. And you can get in touch with me on Twitter at _Jon Vines if you've got any follow-up questions following the talk. So with that, thank you to .NET Chef for having me, and enjoy your break and your pizza.